Hello and welcome to another part reviewer tutorial. Today we'll be modeling a simple machine part as shown here. This is a basic tutorial showing how to use standard features to create this part. I'll recreate this simple machine part in its entirety so you can see how it was accomplished. But first, let's review the Feature Manager design tree on the left. The Feature Manager design tree lists the features created in chronological order. But there are other important items in the design tree. Near the top is the comments folder. Here you can review comments captured for each feature. Just hover your cursor over a sketch or feature to display the comments, or double click a comment to open it to edit it. Next is the annotations folder, the solid bodies folder, and the equations folder where we can create equations to control various variables mathematically. Next is the materials definition for this part, and it's set to 6061 T6 aluminum. Next are the default reference planes and the origin. Next we'll look at accessing commands. There are multiple ways of accessing commands. First, use the command manager and select commands from there. You can add other tabs to the command manager by right-clicking, hovering over tabs, and selecting any one of the other tabs that provide additional commands. You can use the pull-down menus and select commands from there. Tapping the S key on the keyboard calls up a customizable shortcut menu containing commonly used commands. To customize this menu, right-click on the menu and select Customize. The S key is context sensitive. If you're in a sketch, it will show sketching commands. There are also mouse gestures to use. Using the right mouse button, hold it down and slide slightly to call up the mouse gestures. Mouse gesture ring is customizable and context sensitive like the S key. I'll go into each feature in detail when I recreate the part. To start recreating the part, I'll start with a new part file. The first thing I'll do is save locally. I'll give my new part a file name. We'll call it Simple Machine Part. Next, I'll add the material. I'll right-click Material and Edit Material. And this will bring up the dialog for all of the materials that we have. So here I'm selecting aluminum alloy, and we'll scroll down and select 6061 T6. Apply, and then close. Because this part is symmetrical about the vertical axis, I'll use mirroring of features and sketches a lot. The first sketch will be on the front plane and will be for the part base profile feature. I'll right-click, select Sketch, and I'll use my S key to call off my commonly used commands and select the center line or construction line. I'll hover over the origin of the sketch, and you'll notice that I get feedback. It's telling me that I get a coincident relationship. I'll click once and then drag up, and then I'll key in 8 for the height of that line at 8 inches. I'll tap my F key to fit the view so I can see the full length of the line. I'll grab the dimension and simply drag it over to the left. This sketch is symmetrical about this center line. So I'm going to select the sketch, and I'm going to turn on dynamic mirror entities. And I'll get 2 equal signs at the top and bottom of that construction line. I'll tap my S key and select the line command. I'll click at the origin for the first endpoint and drag off to the right. Then I can input the length of this line at 1.75 inches. I'll come up at an angle and wait for the inferencing line to tell me that I'm in line with the other endpoint of the construction line. I'll click the second endpoint and then finish it. Using dynamic mirror entities allowed me to just sketch half of the sketch thus reducing my sketching time. Next, I'll zoom out a little bit and add my next dimension, which will be for the width of the sketch, and we'll make that 6 inches. Pro tip: always fully define your sketches. Underdefined sketches can update unpredictably when dimensions are changed. If I were to remove the 6-inch dimension, notice that the two lines at an angle are now blue in color. I'm also being told that I'm underdefined down here in the status bar in the lower right. If I undo the deletion of that dimension, notice that the sketch is now fully black, and I'm also being told that it's fully defined. Without exiting the sketch, I can go right to my Features tab on the Command Manager and select Extrude Boss Base. Now, my end condition for my extrusion is blind, and I'll change the thickness to 1.63 inches, and we'll confirm our selections. Now, our first feature has been created. Pro tip: name your features as you create them. I'll do a slow double click and then rename it to Part Base Profile. Material must be removed from the extrusion, and I'll use the shell feature to do that. I'll select the front face as the face to remove, and I'll set a thickness of 0.25 inches. I'll confirm my selections. The material thickness not only applied to the side walls, but it also applied to the bottom of the pocket, which has now been created by the shell feature. The next feature we'll create will be the rib that will be internal to the pocket. But in order to create the sketch for the rib, I'm going to need a reference plane that will be offset 1 inch from the inside face of the pocket. So I'll go to my S key where I have added reference geometry, and I can select plane, or I can go up to the insert pull down, reference geometry, and select plane. I'll select the inside face, and then the distance from the inside face of the offset is going to be 1 inch, and we'll accept that. I'll right click on plane 2 and open a sketch. Then I'll sketch a construction line from the bottom to the top. And I'm going to use this line again for dynamic mirror entities. And I'll quickly sketch up the lines that I want. This one will be 1 inch, and then we'll go up 1 inch, and then we'll end it at the edge of the pocket. The sketch is not fully defined yet. Notice that I have blue lines and black lines, so that's telling me that I'm underdefined. I'll need one more dimension in order to fully define the sketch. And we'll go from the bottom of the part to the bottom line, and then we'll make that 4 inches. The green squares that we see on our sketch are sketch relationships. Here we see a coincident. The square with the diagonal line is a symmetric relationship, a horizontal, a vertical, and so on. Sketch relationships can be shown or not simply by selecting View Sketch Relations. Now that the sketch is completed for the rib, we can go to our Features tab on the Command Manager, and we can select rib. Now let's rotate the view a little bit so we can see. Now we need to change the extrusion direction to the normal side to the sketch. And so again, we're seeing that the Material thickness will be symmetrical about the sketch. Let's move it to the second side so that the material is to the inside of the sketch, because the sketch itself is the bottom edge of the rib. My thickness is 0.188. So let's confirm our selections. As we can see, the rib will extend itself down to the face and also conform to the angular side of the wall. The next feature we'll create are the mounting lugs on the sides of the part base profile body. I'll create one and then pattern and mirror it to complete the definition. The mounting lugs are flush with this face here, so this is where we'll open up a sketch. Now let's zoom into this corner here. Using the S key, I'll access the line tool, and we'll the first endpoint there at the vertex. We'll drag over to the right a little bit and make it 0.25 inches. Now if I drag back through the last endpoint, I can pull out a tangent arc. So this allows me to sketch quickly. I'll make this 0.375 inches. And then we'll end it there at 180 degrees. And then over horizontally to the edge of the body. And then back up to the first endpoint. Now if I tap the escape key on my keyboard, I can exit out of the line tool. So this completes the sketch for the mounting lug. Now we can go right into an extrusion, and again I'm using my S key to do the extrusion, and we're going to extrude in the opposite direction, and it's going to be a blind extrusion of 0.75 inches, and this will complete the definition of the lug. The mounting lugs have 5/16 18 tapped holes placed at the center of the arc. So we'll use the hole wizard. So if you navigate to the command manager on the features tab, you will see the hole wizard, or you can add the hole wizard to your S key when you customize it. The hole wizard creates many different types of holes, as you can see. So we've got counter bores and countersinks and tapped holes and slots of various sizes. So we'll be using a standard of ANSI inch. It's going to be a tapped hole, and it's already set for 5/16 18. What we'll need to do is to define the position. So it's going to be on this face, and I'll just hover over the arc to wake up the center point and then place my tapped hole here. I'm only going to be placing one, so I can go ahead and confirm it right there. I'm ready to pattern the lug and the tapped hole. And we're going to pattern it along this edge right here. But I need to know the length of that edge pretty accurately. So I'll go into measure, again from the command manager and the evaluate tab, and I'll select measure tool. And since I've already pre-selected that edge, it appears here. So that gives me the length, and I can right click on it and copy it to the clipboard. And go back to the features tab on the command manager, linear pattern. And that edge is still highlighted, so it's going to be used for direction 1. Here I'm going to paste in, just a Control V, that dimension that I had just measured, and we'll say divide that by 2, so /2 will give me the correct spacing for my pattern. Now I'll select the lug and the hole directly from the graphics area and confirm my selections. And there we have our pattern. We're going to need the same set of lugs over on the opposite side of the part, so there will be 6 total. So in this instance, I'm not going to pattern them again, I'm going to mirror the pattern that I've already created. So I'm going to pre-select the mounting lug pattern here, and then up to the features tab on the command manager, underneath linear pattern, we'll find the mirror command. Now I'll need my mirror plane, and I'll use the flyout feature manager here to access the right plane. And as you can see, we already have a preview of what we're going to get, so I'll just go ahead and confirm that. And there we have our mirrored pattern. The next feature we'll create will be the boss for the V-cut. Now the boss for the V-cut is on the back side of the part, so we'll open up a sketch here. Now I'm going to hold my control key down and my mouse wheel at the same time and span down a little bit. I'm going to access the S key and then the center line. And I'm going to wake up the midpoint of the horizontal line and just sketch a vertical line some distance. Now tap my escape key to exit out of the line command, that I can go select the dynamic mirror entities, and we get the equal signs letting us know that that has been turned on. Now, access the line tool, and I'll watch for the inferencing line to make sure that I'm in line with that center line. I can sketch my first endpoint, and then my second will be at the edge of the part. Now follow along and wake up the inferencing line to let me know that I'm collinear to the edge of the part. And I'll tap an endpoint and then finish by tapping the last endpoint at the vertical line. And that completes the sketch. Now I'll need to add a few dimensions to the sketch. So I'll access the dimensioning tool from the S key. First dimension will be from the top edge of the part to the horizontal line of the sketch, and we'll make that 1 inch. And then from the top line to the bottom line of the overall height of the sketch would be 2 inches. Now you notice that the angular line is no longer collinear with the edge of the part. We could take care of that quickly. I'll just tap my escape key to get out of the dimensioning tool. We'll select the line and then control select the edge of the part. And my pop-up menu will come up and I can select collinear. That makes the line collinear to the edge of the part. Next we'll extrude the sketch. So I'll go up to the Features tab on the Command Manager, select Extrude Boss Base, and it's going to be a blind extrusion. So we'll change the length of it to be 1 inch, and we'll confirm our selections. Now that the boss for the V-cut is created, we can create the V-cut itself. Now I'm going to sketch on the right plane. Why am I not sketching, say, on this face? Well, this face is not perpendicular to the cut that I want to make, but the right plane is. So we'll open up a sketch on the right plane. And first I'm going to use a center line. And I'm going to wake up the midpoint of the vertical line here and just drag across and end it at that vertex. And we'll turn on dynamic mirror entity, and we'll create the first sketch. And that'll just be a short line of 0.25 inches. And then we'll come down and end the sketch there at the center line. Need to add a few dimensions. First dimension will be controlling half the width of the V-cut. That will be 0.5 inches. And then we'll add the angular dimension. Finish this off. That will be 135 degrees. Okay, now that we are finished with the sketch, I'll just tap my escape key to get out of the dimensioning tool. Go to Features, Extrude Cut. Now we're going to cut in both directions at the same time. And actually the Extrude Cut knew to do that. But we also have to keep in mind that we make sure that the right side is being cut. So right now, the outside of that sketch is being cut away. I want to reverse that so that we're cutting everything from the inside of the sketch. And there we go. The next feature will be the mounting boss with the counterbore holes. It is attached to this face, and the backside of the mounting boss is flush with this face. So we'll add a sketch here. I'm just going to pan up a little bit, and we'll start the sketch from here. We'll come down to 1 inch, and I'm going to create a tangent arc again, just dragging back through the last end point, and we'll make sure that this is 0.5 as far as the radius is concerned, and then we'll Finish it at 180 degrees, and then we'll come back over and we'll close it up, starting with the first endpoint. Now I just want to make sure that I've got the center of the arc is going to be vertically aligned with the origin. Okay, now I can go ahead and extrude this, so we'll go back up to our features, extrude, and we'll extrude that 0.75 inches. And again, we're going to have to change the direction of the extrusion, make sure it's going in the correct direction. Let's return back to a trimetric view using mouse gestures. I'm also going to use zoom to area to zoom into this part of the part. And we're going to add a hole wizard hole. This is going to be for a 5/16 socket head cap screw, so it's going to be a counterbore hole. So to select that, it's still going to be ANSI inch, so we need to select socket head cap screw and the size, which is going to be 5/16. And the fit can be normal, or it could be close or loose. We'll just go with normal, and the end condition for the hole will be through all. Again, we just need to select the face that it's going to be placed on, and then we can wake up the center of the arc and place the hole. And again, at my cursor, you see the green check mark to confirm the selection and add the hole. So let's return back to a trimetric view, and you can see the hole there. Next, I'll add the tapped holes that are in the boss for the V-cut. But first, I want to rotate my model around, and I'll tap my mouse wheel quickly to highlight that face. Then I'll hold the mouse wheel down and rotate the model around that face. And again, with the mouse wheel, zoom in. I'll call up the hole wizard, and again, we'll place a tapped hole. Size is 1/4-20, and the air conditions are through all. I'm going to use a 3D sketch. Why a 3D sketch? Because I'm going to be placing holes on 2 different faces. So 3 holes on that face, and then 2 holes on this face. Now I'm going to tap the escape key on my keyboard to exit out of placing points. Now I'll call up my shortcut menu and place a center line from the midpoint of that edge to the midpoint of the edge below it. And then I'll drag this point here onto that line, anywhere on that line. And we'll make sure that all 3 points are in alignment. So we'll control, select the 3 points, and then we'll align them along the x-axis. And I'll do the same thing for the 2 above. Now these 2 holes here are symmetric about the center line of the part, so I'll select the right plane and the 2 points for the 2 holes. And be able to place a symmetric relationship. I'll do the same thing for the 2 holes above. So I'll select the right plane and the points for the 2 holes. And we'll place a symmetric relationship on those. Now we can select, again, the S key to access a dimensioning tool. We'll add a dimension here. This will be 4.5 inches. The one above will be 2.5 inches. These holes will be 0.63 off of the edge. These 3 holes will be 0.25 from the edge. Okay, and we can confirm our selections. And there are the tapped holes. The next set of holes are the countersunk holes for a number 10 screw. And those holes will be on this face of the pocket. So we'll call up the hole wizard, and we'll select countersunk. And we'll say for a 82-degree flathead screw. The size is a number 10, and the end condition will be through all. Now the position, we'll be using a 2D sketch, so we'll select this face here and look normal to it. I'm not going to place points yet. I'm going to tap my escape key and call up my shortcut menu, and we're going to add a center line from the midpoint of that edge down to the midpoint of the edge below it. And we'll select that line, and we're going to turn on dynamic mirror entities. And we're going to go back to placing points, and we'll place 1 point here, 1 point here, and 1 point below it. Tap the escape key to get out of the point command, and then we'll select dimensions. And we'll select dimension between these two holes, and this will be 250, 2.5. And then the two between, this will be 1.5. And then we'll dimension the other sets of holes. From the edge up, this will be 1 inch. And then from this hole to this hole, it will be again 1 inch. And from this hole up to the top set, this will be 2 inches. Then we can confirm our selections. And there we have the countersunk holes. The next set of holes will be 1/4 inch drilled holes on this face of the pocket. So we'll call up our hole wizard. We'll select hole, all drill sizes. The size will be 1/4 inch, and the end conditions to all, and the positions will be, I'll just add 2 holes, 1 here and 1 here for now. Tap my escape key, get out of placing points, and we're going to place a center line, and we'll just drag that up some distance. And then we'll select the points for each hole and the center line, and we'll add a symmetric relationship. Now we'll add dimensions from the edge of the part to the hole, 4.63 inches. And in between the holes, 0.75. Now we're only adding these 2 holes, but eventually we're going to be patterning these 2 holes to finish off the rest of the holes that we'll need. We'll confirm our selections. Next we'll pattern the 1/4 inch drilled holes. So I'll pre-select them from the feature manager design tree, and we'll go up to linear pattern. And we'll use this edge as direction 1. But we'll need to reverse the direction. The distance will be a 1/2 inch, or 0.5, and the number of instances will be 5. But we want to skip instances, so let's open up that portion of the interface, and then we'll select this set of instances right here, so number 3 and 1. So if we go up 1, 2, that would be the 3rd one. So that row right there will be skipped, and then we can go ahead and confirm our selections to create the pattern. The next set of holes are the 1 inch diameter holes that are on this face here of the pocket on either side of our hole pattern. So let's go up to the hole wizard, and we're still using drilled holes, and we've got a size of 1 inch. Our positions will be on this face here, so again we'll be using a 2D sketch. And again, since these are symmetric about the center line of the part, so let's just add a quick center line here, and then create our symmetric relationship between those holes. Add our dimensions. So between the holes is 3 inches. And the distance from the edge of the part is 6 inches. And we'll confirm our selections. Next, we'll apply corner radii to the items in the pocket. So the internal corners need to have some sort of radius on them. Obviously, we're not going to be machining to sharp edges, so for instance, we'll use a 1/2 inch end mill, so we'll have 1/4 inch radii in the internal corners. So from the Features tab on the Command Manager, we'll select Fillet, and the fillet type is just going to be a constant size, and our size is 1/4 inch. And then items to fillet, let's select the first edge, say that corner there. Now we get this filter that we can use to filter through and collect up all of the internal corners. Okay, we'll select that one. And we'll do the same thing up above. We'll select this one here and we'll grab all of those internal corners. Now, if we remember the original part, there are some edges here that are going to be chamfered. So for instance, this edge here, this edge, and we can also select through the part and grab that edge. So everything but those edges will get filleted. We'll add the chamfers to the corners that I had mentioned previously. So underneath fillet, we'll use the pull down to get to the chamfer tool. We'll be using distance and angle. Our distance is 0.25 inches. Our angle is 45. Now right from here we can select the edges where we can get a little closer and select the edges. Now this one here, I can't see that edge, but if I approximate its location, I can select through the part and select that corner. Confirm our selections, and then we have our chamfer. With the chamfer tool, we removed material from these corners. We can also use the chamfer tool to add material. So for instance, the intersection between the boss for the V-cut and the base of the part, we would like to fill in that area with a chamfer. So again, it's just going to be distance and angle, so 0.375 for our distance. I'll select this internal corner, and as you can see from the preview, we're adding material. To complete the modeling of our part, we need to add one more feature, and that's going to be fillets in the internal corners here of our mounting lugs. So again, when we turn to our fillet tool, we'll select the internal corner here along that edge. We'll use our filter to be able to select all of the internal corners on each of the lugs. So vastly reduces the amount of clicks we have to make. Our fillet radii will be 0.25 inches, and we'll confirm our selection. Now this completes the modeling of the simple machined part for the Part Reviewer basic tutorials.